Hey, so I'm making this video as a little guidance in the lab that we're doing. Um, the we've done titrations of weak acids with strong bases before, and this is definitely the type of pH curve that you're probably more familiar with. All right, it goes kind of like this, where we have by now you should realize we go through this region right here, which we call the buffer region, and we hit that equivalence point. Okay. At the point where we haven't added any base, we would have mostly HA, right? At the equivalence point, we're going to have mostly A minus. And again, the reason that we don't have 100% A minus is that if you added A minus, which is the conjugate base to water, some of that conjugate base would react with the water to make some amount of the HA. All right, but still at that equivalence point, you'll have mostly A minus. Right here, you'll have mostly HA. And there's that point, and that point is going to be when you have added exactly half of the volume of base as is required to get to the equivalence point, and that's what we call the half volume. All right, and at that half volume, that's when you're going to have 50% of the HA and 50% A minus. In other words, 50% would exist in the acid form and 50% would exist in the conjugate base form. And what's important about that is at that half volume, if you have your pH curve, if you go over, that pH will be the pKa of whatever your acid was, your HA. All right. So that's the form that we're more used to. And what I want to point out is essentially doing the reverse of this. All right. So let's pretend that we instead of starting off with HA, we started off with 100%, or essentially your conjugate base. All right. So that's what we're going to show right here. This would be if we started out with its exact same conjugate base as your starting material, and instead of titrating that with a strong base, we're going to titrate that A minus, which is a weak base, with a strong acid. All right, and so this is essentially going to be the reverse process. All right, so when down here, I should have written, this is going to be volume of strong acid added. All right, and you'll notice that since we are adding strong acid, we're going to be lowering the pH over time. Okay, so when you do this, you're going to get something very similar. All right, notice that when we were titrating the weak acid with strong base, we had this relatively flat region, which we called the buffer region. All right, well, when you're doing the opposite, when you're titrating a weak base with a strong acid, you get that same buffer region, except for it's eventually going to be going slightly downward. All right, then we're going to hit this sharp drop off, and in the middle of that sharp drop off, we're going to have an equivalence point. All right, so notice at the end of this titration, we had mostly HA. At the beginning of this titration right here, we're going to have mostly HA. At the end of this titration right here, since we're titrating it with a strong acid, we're now going to have HA. All right, so remember, HA would be considered the conjugate acid of your starting weak base. All right, so and so just like we had the half volume when we were titrating with the strong base, we're going to have the same type of situation here, where we're going to have a half volume in the middle of that buffered region. And when you're at that half volume, you're going to have 50% A minus, 50% HA. Well, notice that's the same thing that you have right here. At this point in the titration, you would have essentially the exact same thing in both of these. All right. And so since over here we knew if we went over here, that would be the pKa of your HA. If you do the same thing right here, this would be the pKa of your HA. The only difference here is that the HA is going to be the conjugate acid right here, whereas when you were doing this titration, your HA is the starting acid. What we would consider that just the starting acid. We wouldn't call it the conjugate acid here, because it's the thing that this reaction is starting with, whereas here it's the thing that this reaction is ending with. So, so just for example, in the lab that we're doing, you have, let's pretend that we were titrating acetic acid, all right, with sodium hydroxide. If we were to do that, then this right here would be the salt of the sodium salt of acetic acid, which is sodium acetate. All right. What we're doing in the labs, in your lab, is we're starting with sodium acetate. All right. That is notice that contains acetate. That's essentially the same thing that you would have at the end of this titration, and we're titrating it with HCl, hydrochloric acid. All right. So at the end of that, when we're at the equivalence point, what you're going to have is essentially acetic acid as you're at the equivalence point, all right, which is what you started this this pH curve with. All right. So hopefully you'll recognize that when you're doing what we're doing in this lab is essentially the mirror image of what you would be doing if you were titrating a weak acid with a strong base. All right. Hope that helps. And just want to point out, once you know the pKa of this HA, you should know how to get to the Kb and the pKb of the corresponding A-.